Hello and welcome to another exciting episode of Cooking with Unity. I'm your host, Max Moreau, and I'm broadcasting to you live from beautiful San Francisco. So, today, what we're going to be doing, we're not doing the usual projects because I don't want to get Phil and Jeffery. I want them to have access to it if they can make it, and they can't make it today because I'm not up there. So, we're just doing a one-off. It's called The Illusion of More, and I just want to show that you can lie to players and make it look like more things are interactable than they actually are, and save a lot on CPU time. Lying is done in video games all the time. All of the greatest games that are technologically incredible lie more than any other games because they need to squeeze as much as they can out of a game. And what we're going to be showing is a pretty simple example, but I think it's important to understand that sometimes you want to write around the issue. So, without further ado, let's get started. So, what we're doing is we're starting on the project. This is based on the Crazy Cubes project thing that I love. I'm just so happy with how this turned out. We're going to be seeing this a lot on the show in various forms, probably just because it's fun. But we have 100 cubes, not 100 cubes, it's more than that. 10 times 10 times 10, so 1,000 cubes here, and this is not designed for mobile. This will run on my computer just fine. But if we want to increase the number, it gets bad real quickly. Now, I'm not going to be dealing with the case of shooting the ball right now, just because what we're going to be doing is we're going to be using a simple case where we can lie easier. We might do the ball later if we can think of a clever solution, and I have a few in mind. But right now we're just going to do the walking through the cubes thing. And I want to have it so that we have more than one of these cubes. I want to have like 4, 5, 6 in cubes, just a bunch of cubes that have these physical capabilities, and you can walk through them and without affecting our speed. So right now, if we were to double the number of objects, which we can do by just picking a direction and doubling it. Keep in mind, doubling doesn't mean doubling every value. That's 2 to the third power is what that is, times as many. So doubling, we get. You can see that we're already chugging now. So like the 100 was really right at the edge of what I could do, and if we wanted to do quadruple that, it's even more grindy. Like this is awful. If you couldn't hear me, it was probably my computer not recording anything anymore because it just couldn't handle it. So I don't think it'll actually affect things because of the multi-core stuff, but we'll see. So let's go back to 10. And let's see what we can do here. So the thing is, what I want to do is I want to have more than one of these things. And if you're not near it, you'll notice that it looks like it's a single cube. So let's make a mimic of this cube first. So we're going to create a cube, 3D object cube. And we're going to make it as big as this whole thing is. So each one of these is 5 units, and we're going to make this that size. As a matter of fact, we should actually be exact because we're slightly compressing it. So 4.9 times 10, so that's easy, 49. So we're going to make this 49 by 49 by 49. Alright, and then we're going to just tentatively slap this material on it. So we're going to put monolith on here. And I'm just going to move it so that we can compare the two easily, and we're going to hit play. So, actually, let's make it so that we can compare them both on the same side. Let's just move this here. So, you'll notice that one looks significantly different than the other. You can't see the reflected stuff, and it's all fuzzy. Now, we didn't go into all the detail on how I'm doing the fuzzy effect. All it actually is just random offset of the noise texture, and it just creates that nice little effect. But the problem here is our texture scale is wrong. Also, we have another problem. It's not the same size, so that's interesting. Or is it the same size and I'm just not positioning it nice enough? Let's find out. If we put this at, what's 49 divided by 2? That would be 24.5. 24.5. And let's just leave this where it's at. I just want to make sure that they're the same size. No, they don't look like it, do they? It's not going to the ground, is it? Nope, it's not. The other one's not either. Wait, is it the same size? It is. It just doesn't look like it, but it totally is. There we go. It's funny how optical illusions like that work. So let's actually just copy this component position so that we can directly compare again later. Where is this cube? There it is. And then we paste component values again. And now if we hit play, we can now directly look and compare. So yeah, it's funny that was just the angle and the fuzziness made it so that it looked like it was much smaller, even though it was exactly the same size. So what we want to do is we're going to create a new monolith. I'm going to call this fake monolith. Monolith. And we're going to apply this here now so that we can start tweaking it. And all we're going to do is just the same thing. Because of the size, we had to multiply things out. All we have to do is we have to multiply the tiling out too. So this should be times the number of units, so 50 by 50. And if we hit play then... Wait, that's not it. That's the gloss. Why did it stop? Oh yeah, it stopped animating because... Well, we'll fix that too. So let's first do the tiling. So we're going to do the normal map tiling needs to be 50 by 50. So we hit play now. We're close. You can see that they're very similar except for one's actually like animating and one is not. And so all we have to do to fix that is material effects is what actually handles this animation, and what it's doing is animating the shared material. That way it doesn't have to do this per object. It's much faster. So we're going to add one to this. And we want to do fake monolith, and the texture we want to move is bump map. So, what do we use? Oh, the lightning, that's right. That's how we do the lightning effect too. So if we hit play now, you'll see that they're both very similar. Okay, so they're not perfect yet though. So I must have done something wrong on my math. So first, let's double check. If we go to the regular monolith, what do we have for the tiling? 1 and 1. Okay, cool. Fake monolith, I multiplied it by... Oh, it's 1 and 1. So this should be 10 and 10. I was using my math from the previous values. So if we hit play now, there we go. That looks the same. Now, it doesn't look the same when we walk into it because it doesn't react. It's just a cube, right? So now... What we have to do... Now, we're not going to have the cubes as close together. We're not going to support that just yet. We're just going to show some line here. Now, we can see that things kind of broke here because this is interpenetrating, and these do actually collide with some things. Like, they collide with default, which makes them kind of collide with the ground and it looks cool. But if you have interpenetration, it's not going to line up nicely. That's all that's happening there. So, let's move this thing away. And let's see if we can make both of them look like they are the same. So... What we're going to be doing is we're going to be having one instance of all of the crazy cubes, right? And we're going to move them to the appropriate places so that when you go to a new monolith, it's using the old cubes and it replaces that monolith with these cubes. It's going to be a little bit convoluted, but I think we can do it in an hour. So let's start working through it. So to start, let's create a script. Let's modify some scripts first. So we're going to go to scripts, and we're going to go to grid spawner. Now, for convenience sake, what I'm going to do is I'm going to make sure that all of the objects that we instantiate here are under a parent game object. So we're just going to instantiate it at the 0 point. Like, I'm not sure if you've noticed, but this thing actually spawns kind of from the corner. We're not doing it from the center. It's a little bit awkward to work with, but and we might fix it on tonight's episode depending on how awkward it is. But it's just a lot easier when we're just offsetting from the center. I guess we could always just fix that. Yeah, we'll probably have to do it. It'll be so much easier. Yeah, let's fix it now. So right now, as I said, we're just starting from position 0 and then we're moving out. So position 0 represents the corner of this thing, and we really want it to represent the center of this thing. Do I want to do this right? No, let's not worry about this right now. We'll just offset it for now. But what I am going to do is I'm going to make sure that these things actually are part of the same parent, so that we can work with that. So we're going to parent them to the grid spawner itself. So what we're going to do is we're instantiating game objects, right? So we're going to do game object instance equals instantiate as game object. We're just going to do this on both of them. Oops. And then what we're going to do next is we're going to make sure that all right, so this will be duplicated code. I don't care right now. We're just going to do instance.transform.parent equals transform. So this is making it so that it is now a child of the grid spawner, because transform represents what this is on, not anything else. So we're going to do the same thing down here, and we're going to save. And if we hit play now, we'll see that all of the objects are now underneath grid spawner. So that means that we can take grid spawner, and if I just like shift P for a moment, we can actually move it around wholesale, and the whole thing will move, which is awesome. So so now we have a little bit more useful primitive here. What I'm going to do, I'm just going to do it the other way, because it's fixing it in the code. It's not a big issue, but I just don't want to deal with it. So what we're going to do is we're going to make this thing operate exactly the same, so it's from the corner. Well, not exactly from the corner. That's the problem, right? Because what the problem is, yeah, we'll just do it on both. That'll work. So we're going to change so that this thing has a parent. We're going to create a empty game object. We're going to put the cube in here, and we're going to call this cube parent for right now. Actually, fake monolith. Fake monolith. And we'll just call it cube underneath. And we're just going to make it so that the cube is offset by 49 in each direction. So 49 and 49 and 49. That's not right. That's not all right. Is that right? No. Couldn't be. Could it be? Yeah, that's way too far off. This is not a math night for me for whatever reason. Oh yeah, just half of that. So 24.5, 24.5, and 24.5. That still seems really, really high. So if we do 0, 0, 0, no, that's right. So undo all that. So now if we click on fake monolith and we choose pivot, there we go. It's at the corner. That's exactly what we want. So we want it in the lower in the corner, and that's even the direction that we want it. So we're going to do the same thing with the little cubes though too. And the reason for this is we want it to match exactly, and there's an offset of half a cube here. We could offset it here, or we could just make everything consistent. So I'm just going to make everything consistent. So all we're going to offset is by half the size. So 2.5, 2.5, and 2.5. And we do the same on the monolith interior, 2.5, 2.5, and 2.5. So if we hit play here again, well, they're inside of each other, so that's a problem. That's kind of cool that things jumped out like that. So let's move this over and hit play. And the goal is, if we look at... Here, let's move them. Oh, geez, what happened? Oh, no. Oh, that's what happened. It thought I was moving things. All right, cool. So let's move this over further, hit play, and let's just look at the scene real quick. So each of these cubes should actually be, yeah, at the corner. So if we go to not pivot, if we actually look at the cube itself, and we look at the pivot, totally not showing nicely. Which one is this? Huh, why is it not in the corner? I did do that, right? These are offset, right? No, they're not offset. Why aren't they? Oh, that's interesting. So if we hit play right now and look very quickly, no. Okay, so we can't do that. That's not an option because these things are trying to find their parents and they will get to them no matter the cost. So we are going to have to offset the other one. Detail work, you know how it goes. So fake monolith, we'll just make sure that this is an additional offset of, or a subtractional offset. Why did this change so much? Oh, I moved the wrong thing. So all we need to do is 2.5, so we just subtract 2.5 from each of these and it should be fine. So 22, 22, 22, and if we look at the fake monolith, that should be, oh, it is. It actually, no. Is that right? I'm going to bring in a cube for reference. And we're going to put it nearby. So this thing, if we had this exactly at the corner, that point should be about the same as that point. That looks close enough. I think I just have moved it in the wrong place. So that's what we want. So now that we have the same, so now we can assume that if our fake monolith is in a position and then our grid spawner is in a position, they will take up the exact same space. So let's move this back again. Hit play. Alright, cool. Moving further apart again. So, and what do we want? The position of this thing should be at, normally it would be, what, 2.5 up, but it needs to actually be, or is it still fine? 2.5 up. Yeah, that's right. Okay, cool. So 2.5 up. And we'll just put this at an even 100 because it's just so close and it's driving me crazy. And let's put grid spawner in a similar place. Let's put it at, okay, 0 to 2.5, perfect. So these should be exactly lined up if we go into like the game view, if we go into the scene view and just do top down, these things should be, yep, they're in a line. Cool. So what we're going to do now is on our grid spawner, how do we want to do this? You can do some things with tags, I think, eventually. But let's create a script that create C# script. So what this thing is going to do is we're going to call this teleport to nearest fake is what I'm going to call it. Teleport to nearest fake. And what we're going to do is we are going to, in update, determine what the nearest fake is. Determine the nearest fake. We're going to move determine the nearest fake. Move any cubes that are in out of position back to their original positions. And we are going to we need to disable the fake somehow. We may not do that in the script, but disable the fake, re-enable any other fake that needs to be enabled. 40 minutes. Can we do this? We'll find out. So I'm going to skip the determining of the nearest fake for right now. we're just going to assume one. So we're just going to have a public game object fake. And we're not going to worry about the re-enabling just yet. We might worry about the disabling the fake. So what we're going to do is we're just going to call, this is just going to be our fake. So we've determined it. And move any cubes that are out of position back to their original position. So, so I think checking for equivalence going to be more costly than just setting them all. I think just setting them all will be faster, but we may experiment with this. Let's do for each object. Let's do it. Call it for each transform child in transform. So you can iterate on transform and it'll give you all the children of the object. So for each child in transform, forget if it gives you the current transform as well. I think it just gives you the children. Hopefully, we'll find out. So what we're going to do is child dot local position equals 0 is vector 3.0 and child dot rotation equals quaternion dot identity. So this resets everything to zeros across the board. And if you notice in our prefabs, which if I had noticed this before, I wouldn't have done that little stint where I tried to move these, their position and rotation are all 0. They just are 0. And when we spawn them, they will always locally be 0. And that's actually how they know when they're off. So like if I pull one of these, like if we add 50 to a cube, it'll start moving back to the position. Oh wait, that was rotation, so that wasn't very exciting. But yeah, so if we had it, would start moving back to a 0 position anyway. So we're just going to set them all to 0, and we're going to move the whole thing to. We didn't say move to the fake. Move the whole object to the fake position. And so that means just transform dot position equals fake dot transform dot position. And then disable the fake, so fake dot enabled, no, fake dot set active false. And let's just start with that and see what happens. So if we put this on our grid spawner and we tell it to go to fake monolith, in theory, when we hit play, we'll only see our cubes where the fake monolith was. Oh, all right, so we did something wrong here, and I know what it was. So there's a lot of cubes right there. Doesn't look like a lot of cubes, but there's a lot of them, and it's causing a lot of internal errors because there's too many things on top of each other. That's really bad for physics systems. So what had happened was we set all the children to the same position as opposed to the children of their children. So for each child, transform child and transform, for each transform grandchild in child. Let's try this and use grandchild instead of child here. So if we hit play, did this work? I have a feeling this is still not going to work. Oh, it worked. So if we go in here, they're not reacting to me anymore. Why aren't they reacting to me? Why does it feel like it's slowing down more than usual? Oh, it's because this is happening every frame. So really it's only if we have moved. So we should only do this once. So let's do this as a test case. Let's just put this in a start. Let's just call this start. Save. Hit play. There we go. And now, yay, so it's all good. Let's find out if this is actually too costly to actually work, but we'll find out. I don't know. I didn't try this out beforehand because that's not how I roll. So what we want to do is determine if we need to move. Determine the nearest fake, and if we need to move, then we do all of this stuff. And I'm just going to put it, we're going to tab it over so that we know if we need to move, do that stuff. So what we're going to do is we're going to determine the nearest fake now for real. We're going to, I'm going to go ahead and call it public string fake tag. And we're going to default it to fake. Save. So nearest fake for each game object obj in game object dot find game objects with tag fake. This is kind of a slow operation. There's ways to optimize it, mainly by caching your fakes. As a matter of fact, let's do that. Let's cache our fakes. So we're going to do this in start for real, even though it's already in start. This is actually going to be update. And let's do void start. May as well do this. Cache fakes. So we're going to do system.collections.list. No, generic. That's what we want. We're going to put all of these into here. So for each game object in game object find tag, we're going to do private list game object. Actually, let's do private list transform. Private list transform. We're gonna have to turn them off eventually. What's more important? I don't know. It doesn't matter. Game object. Game object. Fake list equals new list game object. And what we're gonna do is fake list dot add obj. So the reason that this call is slow is it actually has to check every object in the scene, and since we have 1,000 of them, it's better just to cache this. So we're going to cache this at the start. So now we have a fake list that represents all of the fakes that we're going to go through. So in the future, we're going to do for each game object obj in fake list. Same concept, but not from a full set that they have to find in the background and take time. So let's save this. And what are we doing next? So we need to find out the nearest. I really should write a nearest function. We should do that right now. Like for real, because we do this all the time, and it's just silly that we haven't done this yet. So let's do this. We're going to put it in here for right now. Void find nearest, and actually it's not game object, and it's not a void. We need to actually make this, we're going to call this game object, find nearest game object. And it's going to take a list of game objects called object list. And so all we're going to do is, do I want it to be a list, or do I want to do it as an array? I don't think it matters that much. Let's do it as a list right now because we already have a list to work with. So all we're doing is float nearest distance equals math f dot infinity. Sorry, that's not it. Dot in. Oh, why is it uppercase? I'm not going to worry about it. I swear it used to be lowercase. All right, whatever. Nearest distance equals math f dot infinity, and now we're going to go for each game object obj in object list. This is what we passed in. We are going to if obj dot transform minus transform dot object transform dot position minus transform dot position is this should be a minus, and then we do all these dot square magnitude sqr magnitude is less than nearest distance. We're doing square magnitude again because it's faster than magnitude, and we don't care. We only care about the relative things. We don't know. We don't need to know how far away it is. We just need to know what's closest. So we get the square magnitude. That'll be our distance calc. And so if it's nearer than it, then nearest distance now equals this. So that means we should calculate this outside. Float distance equals that. And then we just do distance. Nearest distance equals distance. That's the way. That way we're not calculating it twice. Distance. Don't know why it's not auto-completing, whatever. Oh, it's because I missed a semicolon. That's why it's not auto-completing. Let's hit save. So, nearest distance equals distance. And we're going to create a game object nearest object equals null. And so nearest object equals obj. There we go. And then at the end of all this, we just return obj, nearest object. There you go. So this should, if we use it as a function, just return our nearest game object. So all we do is we just say find nearest game object, and we give it our list. And actually we don't even need, since it's this, we actually just need find nearest game object, fake list. So this should find our nearest game object. So we're going to need to know what our current game object, what our current nearest fake is. So private game object current fake equals null. And what we're going to do is so find nearest game object actually returns the nearest game object, so we need that. So we're going to do we're going to temporarily put this in a different variable. We're going to do game object nearest fake equals find that. And so the reason I want current fake here, we need to set that at some point. So nearest fake is find that game object. If nearest fake does not equal current fake, right off the bat, before we forget, I'm going to at the end here do current fake equals nearest fake. So this is where we actually set it, so that we know that we've set it. And I'm doing it at the end because we're going to be needing both of them until then, because we need to re-enable other fakes. So we should do current fake dot set active true. Now, so that satisfies this. We've satisfied our if. It's sometimes fun to just actually write out comments as to what you need to do, and then you can start building things out. So we move the cubes back into their positions. We move the whole object to the fake's position. We disable the fake. Re-enable any other fake that needs to be enabled. There might not be a fake, so let's do if current fake does not equal null. Then we do current fake dot set active. We don't have to worry about checking for null earlier, because this will actually just return null here, and it'll just not be the equivalent of the nearest fake. So that's great. But in this case, we're trying to do something with it, and that will cause a null reference exception. So this should be everything. So now all you just need to do is go to the fake monolith, go to inspector. We're going to layer is going to be not layer. We're going to tag it with fake. And we're going to go to fake monolith, and we're going to tag it with fake for real. And if we hit play, in theory, it moved over here. It's not working right, and that's because so if nearest fake is not equal current fake, then so it looks like it's messing something up here. So why is that the case? So fake monolith is off. Oh, that's why. Because okay, I gotta see what's going on here. Debug.log nearest fake nearest fake, and we're going to say nearest fake debug.log current fake. I just want to see what it's finding here. So if we hit play, I'm assuming this is just going to be spamming console. It's not. Did it once. And it's working now. Maybe I didn't hit save. That's probably what it was. That's funny. Alright. Save. Alright, let's try this again. So, it's now doing exactly what we wanted to do because that's totally what we programmed. So that's awesome. So, this might all work now. So, if we were to now create several fake monoliths, so let's just place these throughout the level. Let's just duplicate and place, 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 and then we hit play. So now that one breaks up when we get near it, and this one breaks up when we get near it. No, we didn't. Oh, wait. So we're comparing nearest in the wrong context. Nearest game object should be nearest to the player, not nearest to... So nearest game object, and so we're going to put another factor in here. We're going to say game object comparison. No, game object. So nearest game object, the object list, target. Yeah, we'll just call it target. That doesn't make a whole lot of sense. So what we want to do is instead of object of transform position minus transform position, and we want to do target dot transform dot position, and then we need to feed in that target here in our variable list. So what we're going to do is our target is going to be the player. So I'm just going to do game object dot. We're going to avoid the find game object with tag repeatedly. So we're just going to use player. And I'm going to create private game object player equals null, and we're going to cache player player equals game object dot find game objects with tag, or game object with tag rather, player. So let's save that. And now we need to do, where's the player? So we just want to make sure that he's set up properly. So if we click on him, he's not tagged. So we want to tag him as player. Yeah, that's perfect. So if we hit play now, hopefully this will just work. So we go here, totally works. And then we go, should put these a little bit closer together. And it still didn't work. Get any console messages? What happened there? Oh. Huh. not the expected behavior. So if I move over here, all of a sudden they really went someplace weird. Okay, that's because we re-enabled it. Is it not actually moving to the right place? Oh, fake.transform.position. We're not using this anymore. That's the problem. So we need to do nearest fake.transform.position. So now if we hit save and hit play, nearest fake.setActive, and now we hit play. So now I'm relatively certain this is going to work now. I'm excited. So here we go. We push in here, and yay, it totally breaks up. That's awesome. And we get close here. Now there's going to be a telltale sign, maybe. No, it worked. It's possible that some of the glow effects might be extending beyond the border, so it might actually notice when you're close enough that the thing suddenly starts this border glow. But yeah. So now the thing is, if I shoot this thing into pieces, we can break the illusion, and that's the reason I said that we're only really supporting the movement, because as soon as I got close to this thing, it totally did that. And we also noticed just an interesting little problem here too. So if I get close to this thing again, and it breaks up. Oh yeah, the other problem right now is our distance is based on the corners, so it's a little screwed up. So we are going to have to fix that, and we have enough time to do so I'm going to do that. But you can see that here that we now have created the illusion. Now, we would break the illusion because we can't actually shoot the other ones anymore. And if we move too quickly to another one, it will reset these ones immediately. See, reset them. And these immediately start reacting. Now, you'll see that fast. This is actually great that we have the positioning problem. But it shows how this kind of works, right? And the other problem here is if I break these things apart and I shoot them or something, and then we move out, you'll see that did you see how they moved like that? Even though we totally set them to their original positions, we didn't reset their rigid bodies. So we need to do that. So reset rigid bodies. So we're going to do grandchild.rigidbody.velocity equals 0.0f. And we're going to do the same thing for, and actually it needs to be vector 3.0. And rigidbody.angular velocity, which also is represented as a vector, right? Yep, just another vector 0. So that'll fix that problem. Save, play. So there we go. And then we got this one here where we go into it. It's all awesome. And so if we shoot this thing, so what was our really good close by case? What was the one that worked out nicely for us? I think it was these two. Yeah, these ones are nice and close together. I guess we could make a really nice hackney case. So we're going to blow this one away a bunch, and we're going to move away, and you'll see that it didn't judder like it did before. So that's great. The other thing you'll notice is as we get close again, these just reset. And that's going to be there no matter what, but we can make it at the very least so that it looks a little bit better just by fixing the offset problem that we've got, because it's really hurting us. So remember, all of our cubes and fake monoliths and stuff are offset, and I have to actually change all of them manually, which I'm not going to do. I'm just going to delete all of them. And we're going to create a prefab before I forget, because then I could have changed it really quick, but as it was, they weren't prefabbed, so it wasn't going to be quick. So we're going to just change the position back to 0, 0, 0, so that it represents the center of the object. So we don't have this offset problem. Now we need to do the hard part. We actually have to, well, it's not hard, but I just didn't feel like doing it earlier, and we have to do it, so I'm doing it now. So we're going to go to grid spawner, and we need to offset these things the proper amount. So let's kind of make this a little bit more readable. So we're going to you can put as much spacing in your code as you want, including new lines. It doesn't affect anything. That's the reason you need semicolons, actually. This represents the end of a statement. A return does not represent the end of a statement. So we do times x times... Oh, wait, no, this is still part of the same thing. So it doesn't matter. It would still compile. I just want to organize this in a meaningful way. So we're going to do the x value plus the y value plus the z value. And we might as well just do this because it wants to do it anyway. So transformed up position, and we'll do this as well. So we're just going to separate all of them. So this is our position. We add the right times the x times the object scaling spacing. We do the up and we do the forward. So what now we want to do is we want to additionally offset based so that this becomes the center as opposed to an edge. So how do we do that? We can offset by half the ultimate size of this thing, right? For each dimension. So what we're going to do is transform.right times x times object spacing dot x. So let's offset the original position. Let's see if this will work. So transform dot position minus transform dot right times it's basically going to be this so it's this thing times object spacing dot x and we want this part to be divided by 2.0f. So let's do these as individual things. So we're going to do a minus, and we're going to do the same thing here, and we're going to do a minus, and we're going to do the same thing here, and then plus. So transform position minus, and this is the initial thing to offset us the other thing. There probably is a faster way of doing this, but I just am doing this for right now. We want to see if we can get something that works first, and then we can optimize later. And additionally, this happens once. This is a one-time generation. As a matter of fact, we could do this really offline, and I'll show that on another episode when we do more editor tool stuff. So transform.right, transform.up times y, not t, y. And transform dot forward times z times z. And we do this in both cases. So what was the difference here? Just what we're instantiating. So we can just literally copy this whole thing, put it in here. And this format also allows us to do some commenting. So we could do like our original position minus for center offset x y. Oh, and we don't need a z here. This is actually wrong. We actually just want the object spacing. But we do want that to happen for... Actually, that probably doesn't matter, but I'm still going to keep the brackets there because it might matter. I don't think it does, but it might. Minus for center offset z. And then we do plus current offset y. X, Y, Z. And let's just copy this into the other thing again. And we don't need that extra comma. And what are we doing? We just need to change this one from shell game object to inside game object. Save. So let's see if this works. So if we hit play right now, hopefully, if everything's right, this thing will be, yeah, that looks pretty promising. So let's actually disable the script that makes it go to the thingy here. Let's go to our grid spawner and just temporarily remove teleport to nearest fake. And so there it is. And is this thing halfway through the ground? It's not halfway through the ground, so it's not good enough. Yeah, that's not good enough. So if we click on the grid spawner, pivot, yeah, the pivot's not in the right place. I did save this, right? What else? Yeah, I did. Object spacing.x. Oh, wait, yes, we do need something. So instead of this being just object spacing.x, we need it to be object spacing.x times the object spacing.x times the number of objects total. So num. So this one I did z to, yeah, so it'll be num objects x times object spacing.x, and we needed those brackets anyway, so that's good. And we will do the same thing here. And this doesn't need to be here twice. So, and then we need to make sure to not make the classic mistake of not actually changing our variable names in the appropriate places, which I've done enough in my life to abhor myself. And we're going to hit play. And hopefully this thing will be sunk halfway into the ground. That's looking promising. And so if we look at it, its pivot and its center should be the same. They're not quite the same. So that's that slight offset that I was talking about that we need to fix, because this represents the offset if, so yeah, one's in the center of a cube and one's, well, no, that's not true. But anyway, it's wrong, whatever it is. So we just need to change the offset slightly based on the object spacing. So it's probably objects.x. Let's see what happens if we just do -1 here. No, that doesn't make sense. We need to just offset it at the very end. Divided by 2.0f minus 1. Sorry. So it would be half the 2.5f. Let's see. It might be a +2. We'll find out. So we'll just do this happens at the last part. We still need num objects. I don't know why I'd gotten rid of that. So we still need num objects x times object spacing.x, and then we do a final offset. And does this compile? Does this go as a compiler? Feels like it's going to. Yeah, it did. All right. Unexpected symbol where? That's a weird place for it. Okay, yeah, that's not enough. So this, oh yeah, we need to do that. There we go. That should fix it. Save. Does that compile? Good. All right, so let's go ahead and do this on each of these. Naturally, it's the simple math stuff that is causing me to run out of time here. Y, Z, and we're just going to grab all these and put them in here. And we're going to hit save. Didn't blow away anything important, right? So now in theory, this will be either more off or less off. So we're going to go to our scene, and we're going to click pivot and center. That's perfect. The only reason there's any offset at all is because one of these is out of place. So that will work now. So now this thing is on the ground, right? So we can just use its transform. So it's just position minus, wait, how is it on the ground? Did we not offset it properly? Oh yeah, we're still offsetting something here. We don't want to do that. So we want fake monolith. Let's apply this to our fake monolith. And we're going to need to move this thing way up. So 2.5 plus 49, so 51.5 maybe? I was going to put a question mark there, but it won't let me. So if we do that, no, that's too far up. Oh yeah, that's right. We need to do half of it. So 24.5. Let's just do that and see if it's sunken. It probably will be. We'll just offset it by another 2.5. So scene, is that right on it? No, that's right on it. That's exactly what we need. Okay, cool. So we do the same thing with the grid spawner. 24.5. Hit play. And there we go. And this doesn't work right now because we didn't hook it up right. So now let's just create a few fake monoliths. Duplicate. I'm just going to make them really close together this time, which will illustrate our problems again, but at the very least it'll illustrate our solution as well. Save project, hit play. Oh yeah, and actually enable our script on grid spawner so that it actually moves and disables things so it doesn't blow itself up the moment it starts. So there we go. And then when we move back here, we're just like, and then when we move back here, we're just like, and it just feels like we can just do whatever we want. And the world just crumbles before us. Now, of course, if those cubes stay just in vision while I move to the next thing, they're going to pop. But it's a small price to pay for the performance, and you can design around that potentially by making things further apart or making it so that you can only travel in one direction, which makes it much less of a problem. We might revisit this later and try to be a more robust solution, maybe something that can also support something like that, and actually still feel like all the cubes are there, even though the same number of cubes are there. Basically, we could do some sort of, if two objects have to be enabled, we can enable half the number of cubes in each of them. It'll still kind of sell the effect. But I'm going to leave that for now as an exercise for you guys. So hopefully you like this. I know that some people get upset when I teach them about cheating because they're like, well, that's not how it's supposed to be, except for the fact that cheating is part of the game, man. That's how this stuff works. Games do it all the time, especially older games. They had no processing power to work with, and so you see a lot of interesting solutions to problems. We're going to show more cheats on the show, certainly, but just don't let the sleight of hand bother you. And again, if you want to work on this later and you come up with a really great solution, share it, man. Either share it with us and I'll put it on my show, or just make your own show, or whatever you want to do. Just put your knowledge out there if you find something cool. Hopefully you like the episode, and we'll just do the thingy here. Hopefully it even came through. If it didn't, this will be re-uploaded, as I said. So just the face. Thanks for joining us. Hope you had a good time. I had a great time. It's nice temperature here in nice, beautiful San Francisco. You guys have a great night. If you have any questions, email me, pushypixels@pushypixels.com. Support me on Patreon. Either search Patreon for Cooking with Unity or look in the hamburger. There's a link up there. It's not up there right now, probably because it's only on the front page. So go to unity.rocks or cookingwithunity.com. Either one will take you to the front page, and on the burger somewhere it says Patreon or support us or something. So thank you very much. You guys have a great night, and I will see you. I'm probably not going to see you tomorrow morning, but I might see you Wednesday morning, and I should be regular schedule after that. So Thursday, Friday, and Thursday night. So have a good one, and you guys have a great night.